So for those of you who don't know who I am, I'm Dr. Pamela Gay. I'm on the faculty at Southern Illinois University, Edwardsville, and I'm part of the team that puts together the Astronomy Cast podcast. My co-host is Fraser Kane of Universe Today. Now, I have been asked to speak before you today on the types of things that people claim are true about astronomy that just aren't. Now, we all have our favorites of these, the things that people say, and you just sort of question how they tie their shoes in the morning. Now, this year, 2012, has brought many of these things to light, and people seem to be embracing their inner idiot. And sorry, I will try and make sure no one is drinking next time I say something like that. So I think one of the things that I find the most mysterious that people are able to embrace is the idea that there's this planet X, this planet Nibiru, this second sun that is on its way into the inner solar system where it is going to destroy the planet Earth on December 20th. And oh my God, don't you just know? And the thing is that the planet Nibiru claim has been around for a while. It first came out back in the late 90s when we had Hale-Bopp in the skies. This was the comet that unfortunately several people committed suicide when they saw. And it was felt that this comet was coming to take us all. And it didn't. And this was then claimed as a great conspiracy. And this year's is a bit more mysterious because with Comet Hale-Bopp, there was at least an object that was legitimately coming into the inner solar system. This year, there's no such thing. And so they're all claiming NASA cover-up. But the thing is, the sky is owned by all of you. Any one of you could go out tonight and explore the entire northern sky with binoculars, hop on a plane, fly 10 hours, explore the entire sky from the southern hemisphere, and very quickly rule out that there's something on the way to get us. The reason is space travel in general is a slow process. And if there's a naturally occurring object, a planet, a star, on its way into the inner solar system, it would be visible already. We see chunks of ice out in the orbits of Pluto, no big deal. We detect them regularly. We see all of the planets, and Jupiter and Saturn easily visible with the naked eye. If there was another star coming, we'd be able to see it as easily as you see Jupiter in the twilight sky right now. None of this is being seen. So the next time a crazy person chooses to tell you that on December 20th, the reason the world is ending is because planet Nibiru, planet X, or the Death Star, actual star of death, is coming in, ask them to go outside with you with a pair of binoculars and find it in the sky. And when they can't, and they try to say, oh, it's just a NASA cover-up, say, no, no, no. It would be reflecting sunlight.
If it was a solar object, it would be radiating.
If it was a stellar object, it would be radiating light. Stealth technology doesn't actually even work for this because it would be blocking stars out. So you lose no matter what direction you go in trying to deal with this one. It's just so frustrating that people are trying to claim that there's all these points of conspiracy in the world, and just the fact that you could look up with your eyes seems to be getting completely not paid attention to. Now the other thing that's coming up with our whole 2012 end of the world is the whole Mayan calendar thing. The Mayan calendar is no different than the hour hand on your watch. Does the world end at every passing of the hour? Sometimes it feels like it. Doesn't really. Does the world end every time we get to the end of the leap year cycle? So what we're hitting is just the end of a cyclic calendar. Yeah.
Didn't they just find a Mayan calendar that goes on past?
Yeah, and they did just find a Mayan calendar that keeps going. And it's not so much that they found a calendar that keeps going, but they found things that talked about after the end of this particular cycle. And so they name their cycles, and the particular cycle that's coming to an end now is one of their more important ones. But it's sort of like the end of the Year of the Dragon. The Year of the Dragon's kind of awesome if you're Chinese. But the world doesn't end when it ends. Now, the thing about the Mayan calendar is these were very observationally driven people. And they watched patterns very closely. And so they were waiting to see when do all the patterns line up again. And there's a lot of patterns to take into consideration in our wildlife, in our sky. And they worked to put all of those together. So they looked at what is the number of years between Venus being in the exact same place in the sky and Venus being in the exact same place in the sky, and the sun being in the same place, and the moon being full on the same day, and getting all of these celestial events tied together with the seasons. And then they started throwing in biology. So they took into account the 9-month cycle of a woman giving birth, the roughly 28-day cycle of a woman's menstruation. All of these different things got tied into the Mayan calendar. And it's just when is the next time we get a whole number? It's that lowest common denominator problem from middle school. And we're about to hit the lowest common denominator. It repeats. It's okay. So next time someone tries to tell you, well, it's the end of the Mayan calendar, you now know all these strange things that go into it that are simply going to repeat. And usually when I point out that the biological cycles are pointed in, they get confused and they don't know how to react. It's a good way to at least escape a conversation with a crazy person. Oh, please come in, sit down. There's chairs all around. We're friendly.
Thank you. I'm a Capricorn, by the way.
Ophiuchus. The constellations are actually one of my favorite ones because so they originally came up with our nice 12-month cycle back, and I'm going to screw up which pope it was. We currently have a Gregorian calendar, so it was a Julian calendar originally. So when they came up with the Julian calendar, they didn't have enough leap days. So over the course of several hundred years, Easter started to move. So when Easter was no longer corresponding with the sun where they wanted it for spring and everything else, basically the church got together and decided we need to figure out how to fix all of this. And so it was actually a bunch of cardinals who sorted out how to fix the calendar, shifting to the Gregorian calendar so that we had a more correct number of leap days so that the date of the solstices and equinoxes wouldn't slip relative to the calendar date in the same way. And this is where we end up with crazy things like leap years in years that are intervals of 10 except for, intervals of 100 except for those that are intervals of 1,000. So the year 2000 wasn't a leap year, but the year 1900 was. So all of these different things to correct the calendar were simply to keep the solstices and the equinoxes roughly on the same calendar date every year. Now, when they moved the entire calendar, they did not move the astrological symbols that were associated with birth dates. This is a bit odd. Now, some did, but not everyone. So this means that when you look up the symbol that represents your astronomical sign, it's off. So you go into planetarium software, something free like Stellarium, or spend the big bucks and get something like Redshift. And when you look at what constellation is the sun in on the day of your birth, it's often not the astrological symbol that the zodiac in the newspaper says. And then the other curiosity is there's this extra constellation, Ophiuchus. If, like me, you're born in the right part of December, I'm born December 12th, the sun's actually right in the middle of a serpent. That's not part of those normal zodiacal constellations. So there's lots of strange things tied into astrology, but I think the thing that matters in a lot of ways, the most in terms of predicting this, is if,
So we're snakes, not hunters.
snakes, not hunters. Well, it's more a matter of think of all of the national events that not one astrologer basically wrote, everyone is dying today. Pearl Harbor wasn't predicted. 9/11 wasn't predicted. And so when you look at these things, sure, there are certain things that seem to make sense. And the argument I often hear is, but Sagittarians really are strong-headed. Yes. But when people seem to start making sense with this research, and occasionally you'll confront someone who actually does start to make sense with this research. There's a couple of really interesting papers that came out in the past 2 or 3 years that looked at what is the weather pattern of a gestating woman and the sun-night cycle during the last part of her cycle. And what they're finding is babies born in winter, especially in extreme northern or southern latitudes where there's limited daylight, and who have mothers who have seasonal affective disorder, often have certain characteristics. Babies born in summer when there's lots of sunlight, when there's a strong day-night cycle, have a different set of characteristics, and it actually affects biorhythms. People who are born in the winter have much less tightly set biorhythms. I read this and I was like, it makes sense. Because if you take a rat and you put the mama rat in a dark box, keep her in the dark box the entire pregnancy, her babies have almost no day-night cycle. So you keep them in this not really day-night cycle environment, and the baby's like, I don't know when I should sleep, and they sleep randomly. And I'm kind of that baby rat. Now, if you take a baby rat and put them through the gestation cycle with strong day, strong night, keep that going after they're born, take away the sunlight. They maintain that I need to sleep, I need to be awake periodicity. So there are chemical effects, environmental, seasonal, biological, real effects driven by how we react to sunlight that do affect personality. And so when you're claiming astrological signs dominate personalities, see if it applies to the southern hemisphere. Or see if what you're actually seeing is a real cycle that's driven by biology. Because those things exist. Yeah.
On the other hand, it could be just about social conditioning. But so you're a Gemini, you're going to act like such and such. You might start acting that way.
That's true, but most people nowadays don't get that sort of socialization. So it's as they hit teenagers and they get paranormal curious that you start seeing the, oh my God, this is so real. Let's go get the tarot cards and the Ouija board. I think most teenagers go through that religious curious, paranormal curious, oh my God, do ghosts exist, trying to hypnotize each other. It's one of those strange rites of passage. Yeah.
May I suggest it's because teenagers feel particularly uncertain about the world, and magic helps make things more certain.
So the comment that she just made is teenagers feel naturally more uncertain about the world, and magic somehow makes them feel more certain.
Plus they can prove their parents wrong.
Plus they can prove their parents wrong. So I think in this age where there's less and less conditioning from early childhood about what a different astrological symbol means to your personality, that it's people simply finding truth wherever they can. And so we just need to be careful to separate out the, that's just plain wrong, from the, I wonder if there's something to this that we can pin on how we react to different amounts of sunlight, to just something that, well, that applies to everyone, so just move on with life. All of these different things come into play. So, sorry, my screensaver keeps coming on. So another one of the things that's related to this whole 2012 debacle that we're living through. For those of you who don't know, I personally will be spending 2012, December 20th, at Mayan ruins. There's a whole group of us, and you're all invited to join. The cost isn't that exorbitant. We're going on the World is Ending cruise. And if you Google Pamela Gay world-ending cruise, you'll find out how to sign up for this. And it departs out of Miami, and it's going to be a whole bunch of us having geeky, stupid fun on a Norwegian cruise line. And I love archaeology. And so it's just really cool that we get to go see the Mayan ruins. I don't care what the date is. I'm just happy to get to go. And so there's going to be David Brin, myself, Fraser Kane, whole group of awesome people. So you're all invited to join us. But one of the things that people keep claiming is going to be true for December 20th, that it's just sort of like, WTF, guys, is they're saying that there's this special alignment between the Earth, the Sun, the center of the galaxy. Now, the thing is, that happened on December 21st, not 2012, 1998. We survived it. We're all here. It's completely fine. And more or less, this happens every single year. This is that whole Sagittarius problem that we were just discussing. Every December, the sun is in the constellation Sagittarius. The center of the galaxy is in the constellation Sagittarius. In fact, there's this little X-ray beacon we call Sag A star because we're lame when we name things. And back in 1998 was the best alignment that there's going to be between the Earth, Sun, and Sag A star until we orbit back around the galaxy in a few hundreds of millions of years. There's a difference between next December and a few hundreds of millions of years. So
But you'll be taking a cruise then, too.
I will be taking a cruise then. So not to worry, you've already survived the massacre. It's all good.
That should be a t-shirt.
You've already survived the massacre.
Oh man, I should get that printed, you're right. Okay, watch astrogear.org, that will be appearing. Thank you, whoever spouted that out, come tell me later, or you'll help me with the design. And I'm not joking.
When I was Mike was Armageddon was yesterday, today we have a serious problem.
For those of you who didn't hear, he said, Armageddon was yesterday. Today we have a serious problem. Okay, so those are all the kind of classic, wow, you're crazy issues that we deal with. Now the problem is there's a lot of misunderstandings that aren't crazy people. They're people who just don't understand. And what was kind of funny is the difference in what annoys astronomers the most and what annoys skeptics the most. I actually tweeted earlier today about, hey, I'm going to be doing this talk. What are the misconceptions, hoax-like things that you think I should talk about? And I get all these astronomers coming back talking about phase of the moon. Now, how many of you have ever felt morally upset that someone didn't understand the phase of the moon? Okay, there's a few people in the room. And there's not a projector. Okay, I can't do the demo I was normally going to do. Okay, we can pretend. So one of the things that leaves me most confused, and I sort of get where it comes from, is there's this societal misunderstanding of what causes the phases of the moon. There's this belief that the Earth's shadow gets on the moon and causes it to be quarter phase, causes it to be new.
I don't see it as a shadow, it's the Earth blocking the sun.
See, you're one of them. I love you dearly, but you're wrong.
That's what I was told.
And this is the problem.
That's what I believe, it's just
Yeah.
what the teacher said.
But the teacher said, and I have to admit, I taught for 2 years pre-service teachers. The best ones were awesome. The worst ones made me question humanity and opt not to have children. My favorite, to distract myself from my own chain of thought, my favorite stupid student, there are stupid questions. We were talking about gravity. Gravity is what holds mass together. You are mass. You are held to the Earth by gravity. You could walk continuously all the way around the planet, and this line would connect your center of mass, which is slightly below your belly button if you're a woman, around or above your belly button if you're a guy, because we're built differently. And your center of mass is getting pulled towards the center of mass of the Earth, which is in the center of the planet. So 2 stupid student tricks. First student, I'm working to explain orbits to her. So I draw on the chalkboard, here's the Earth, here's the moon. And I said, okay, draw the arrows connecting, or draw the arrows showing the force of gravity on each of these objects. She walks up, she draws a point in the center of the Earth, draws an arrow towards the bottom of the chalkboard. Goes to the moon, draws an arrow in the center, drops it towards, so both the Earth and the moon are falling towards the chalkboard tray. Fast forward 4 years. That was a Harvard student, by the way.
Future leader of our country.
Fast forward 4 years. I'm now teaching at Southern Illinois University in Edwardsville, teaching gravity to a room full of teachers. I tell this story as a don't ever make this mistake because I will mock you for the rest of your lives. And I actually tell my students that. And we're getting along in the conversation. We're having a good discussion about gravity. And this sweet, sweet girl, she was one of the nicest students in the class. She raises her hand, and I've taught my students to feel comfortable asking me anything. And I promise, in general, the exception being if they don't come to class and fail their exams, not to mock them in class. I'm not in class. Sweet, sweet student. And she raises her hand. She's like, Dr. G, because they can't say Dr. Gay, it's the Midwest. Dr. G, I love my students. I honestly do. Why don't the oceans and the people all fall to the equator at the middle of the planet? This is a college student, a pre-service teacher. And I don't understand the question for a minute. And I realized that there's a three-dimensional thinking issue here. I've carefully taught my students the center of mass idea. But the fact that it's a three-dimensional center at the center of a sphere is something that she hasn't quite gotten. And so she knows things fall to the middle, fall to the equator is what she thinks it should be. She's struggling with this concept. And we got her through it. And by the end of the class, she understood. But this was one of those eye-openers to me. Because this is someone who was struggling to understand, who was earnest, who was sweet, who was so nice, who's going to be a special ed teacher someday. And no, special ed is the hardest thing you can possibly teach. It is the absolute. I had one autistic kid in my class. I almost didn't make it through the semester. It was the hardest thing I've ever dealt with. And anyone who's a special ed teacher, I couldn't do it. My kudos off to you. And she's going to be great because she's infinite patience. But that day, there was this concept that three-dimensional thinking is hard. And she was trying. And she made a mistake to end all mistakes. But she tried. And she learned. But when we're dealing with astronomy, we're struggling to teach these three-dimensional concepts to people. And teachers struggle. And then they go into the classroom, and they're not allowed to struggle anymore. And so now they're teaching concepts that they may not have understood. They may not have felt safe asking the dumb questions, because there are dumb questions. You just can't tell the student they're dumb when they're asking them. And so then you end up with people who have misconceptions. So the thing about the sun, and I searched my hotel room and the vendor room, and I couldn't find a three-dimensional sphere I was willing to spend money on. So we're going to go with cylinder. It's good enough. Actually, can I steal your coffee mug, sir?
I'd be glad to.
Thank you. Okay.
Use it.
Okay. I promise not to spill the liquid inside because I suspect is caffeinated, which makes it awesome. Okay. So we have a nice three-dimensional surface here. Now, if that entire wall down there was illuminated, where would this cup be illuminated? So it would be this entire half. Now, if I'm looking at the cup, can I see any of the illuminated part of the cup right now?
No.
Now, the reality is if the cup were the moon, it wouldn't be directly in front of my eyes. We're going to say my face is the planet Earth. Because the way the moon orbits is I can't imitate day cycle and lunar cycle simultaneously. So for a minute, we're going to tidally lock the Earth and the moon. So as the moon goes around, it increases in height and decreases in height as compared to the Earth-Moon or Earth-Sun line. Now, sometimes the low point is in line with the sun. Sometimes the low point is here. This month, when we have eclipses, it's actually directly in front. We have a lunar eclipse next Monday. We had a solar eclipse last Sunday. This is because this is the way the moon, this is the midpoint, so it's on its way up, on its way through middle here, on its way down here, on its way back to here. So currently, the two middle points in this tilted disk are in line with where the sun is, such that I see nothing illuminated right now.
Okay.
Now,
That makes a lot more sense.
so, yeah. So now the thing is, I'm going to actually do it in the correct direction this time. So if my head is north, the direction things rotate are you put your hand over your heart and follow your fingers. So I'm following my fingers around. Now, has the part of the cup, the part of the moon that's illuminated, changed at all?
No.
Sun's still over there. It
You
hasn't.
rotated the cup with your hand as you go around. So,
Well-
so if you had markings on the cup, the illumination has changed.
So the part of the cup that is illuminated has changed. And if you notice, I'm keeping this piece of tissue facing towards me. We always see the same part of the moon. So that's actually realistic. This piece of tissue is staying facing me. So the part of the moon that's illuminated, that's changed. But has this geometric side of it oriented to space changed? It's still the half. Now when I look at this object, I see half of it illuminated.
Okay.
The other half's in shadow. Now full moon, still have the tissue facing me. How much of the cup do I now see illuminated? All of it. We call this full moon. Earth's shadow is headed towards the moon. This Monday, it's going to be lined up like this. And I accidentally pulled off the tissue, so let me put it back on. This Monday, the Earth's shadow will be on the moon. That's called an eclipse. Doesn't happen every month. Happens twice a year. So this month, the moon goes into the shadow. Normally it's up here, and what do I see? Full moon. Keeping it around, keeping the tissue pointed towards me, I see another half moon. This time it's the exact opposite half. And now I'm back to seeing no moon again. That's where we get the phases. But people get so confused because their teachers, their neighbors, their parents, someone who didn't think. And that's all it is you're in the moment, there's a 3-year-old in front of you. How do the moon's shadows get... And you make shit up. And where else do phases come from? Shadows. The fact that it's the moon casting its own shadow on itself. Because it's a 3-dimensional object. This side of the moon kind of blocks light from hitting this side of the moon.
So when it's here, Pamela, we're just seeing a crescent, right?
Yeah.
A tiny
Yeah, so
sliver
right
on the
here,
very end, yeah.
and the crater fell off. Right here is crescent, and this is actually about where the moon is right now. So if you go out tonight, it's going to look kind of, actually, sorry. Yeah, that's right. It's going to look kind of like this.
Well, when it's, if I may, 2 questions. When it's really right directly in front of you, go ahead and do it. There's the sun. Your
Yeah.
nose is you. And do we see nothing then? Does
We see absolutely nothing.
the moon
Black.
actually disappears?
The only thing that we see,
Disappear.
yeah, it does. Totally
To
disappears.
our view. is
Well,
what
to
I
me,
feel.
it looks black. It doesn't.
At noon. So the thing is, right now, my nose is getting illuminated by the sun. It's high noon and the sun is up. So I'm now rotated over here. It's now sunset because the sun and the moon are both over here. I'm looking over here and I can't really see the moon because it's lost in the glare of the sun the entire day. So you never see the sun on that day.
Well, that was my second question. Don't I, maybe I'm misremembering, but don't I sometimes see crescent moons at night?
Yes, so the trick is, when does which thing set? So here we have the sun straight in front. Here's the crescent moon. Nose is my observer. So right now, high noon, I can see, if I have a telescope, crescent moon near the sun. Day is changing, wishing arms were longer. It's now sunset. So sun is on the horizon, moon is still up. If I keep rotating, I can't move my arms anymore, but I can move my nose. I now have the sun set, and the moon is still the only thing in the sky. Right. So as you go to having the moon further and further away from that sun, it sets later and later. Until finally, I get the moon over here, and I have a full moon that's high in the sky at midnight.
So if I have this right, I never see a crescent moon at midnight.
Exactly. You only see the crescent moon near the sunrise and near the sunset.
Sort of like Venus. You also
exactly.
never see Venus at midnight because it's always somewhere
It's always
here.
Near the sun.
It may be over there, maybe over here, but it's
And-
never
Maybe
on
also
that
called
side,
morning
right?
star.
And you'll
Unless you were in one of the poles, you might be able to see it. I would say. You really want to look at all the
That's called white nights and full
okay,
nights.
there you go. Okay, got it. Yeah.
Yeah. So
So I'm sorry to keep, but
no, it's fine.
The same reason that I only see Venus at sunset or sunrise.
Yes.
Is the same reason
It's
I only
because
see a crescent moon
it's
at
always near the sun when it's crescent. And you can see the quarter moon. And this, I got a test question so wrong with all the right math when I was an undergrad. Because new moon, that's easy. Can't see anything. We call it new when you can't see it. Full moon, totally understood that one. Right here, you see half the moon illuminated. Test question was, calculate the location of the moon relative to this, that, and the other thing. At quarter moon, full, half, quarter. I was thinking in 2 dimensions. I did all the math for the moon right there. Right here, 3-dimensional moon. I'm seeing this quarter of its phase. So we call this first quarter, new. First quarter is when you look up and the right side is illuminated. Full moon.
Why is it called full when it's only half then?
Because astronomers can't name things. and it's third quarter when the left-hand side's illuminated. For the northern hemisphere, reverse for the southern hemisphere.
He's right, though. If you call this a quarter when it's really a half of the
I know.
call that a half.
I know. We can't. And this is why I got the test question wrong, because I was being that kid. Now the other thing is, people screw up, is the moon rotating or not? Remember my silly piece of tissue. Piece of tissue is always facing me. Did the moon rotate? Yes. It rotated one entire turn while it orbited the Earth. And that's where people really get confused. So now you know it's not shadows. But that's the easy assumption, especially when there's a 3-year-old torturing you. Yeah.
Which is why it is important with people who are regularly faced with 3-year-olds to memorize the phrase, I don't know, let's look it up.
Yeah, she just made an awesome, it is so important, especially when you have small children with awesome memories. Don't ever make things up. Think of Calvin's and Hobbes' dad. Don't be him. Fair? You all promise no lying to small Calvins? So related to the phases of the moon is this concept of the supermoon. I hate the supermoon. And the reality is we have a supermoon about once per year. What's happening is that orbit that I just made for you, it's in reality, here you have the moon here. Here you have it here for our two extremes. Here it's closer, here it's further. We call this perigee, we call this apogee. And it happens all the time. But what's special is sometimes you end up with perigee when the moon is new and thus closest. Sometimes you end up with it when the moon is farthest. And it doesn't do very much. The moon is roughly, I'm going to get the numbers correct, so let me make sure I don't get any of the numbers wrong telling you this. It's, sorry, inadvertently scrolled in my enthusiasm with my iPad earlier today. It is 7% larger and 15% brighter. So it's actually a good time to go take photographs. But these differences don't have a geological impact just because the moon is full or new. Gravity only really cares how close the two objects are. And yes, there is added gravity when you have the moon and the sun in a line, or the sun, earth, moon in a line. But as far as we know, this doesn't have an effect on volcanoes erupting, on earthquakes going off. And the thing that everyone keeps trying to point to is last year's horrific tsunami in Japan that occurred roughly half a week before the supermoon. Now, the problem with this is the time that it takes to go from new to full to new again is about 4 weeks, which means 1 week out, you're over here. That is not a supermoon. That is an average distance moon. So the moon was roughly at an utterly average distance from the Earth, and it was not lined up on an Earth-Sun line when this horrific event happened. People like to find reasons for bad things. They like to blame something. How many times have you stubbed your toe and then blamed whoever left the object on the ground? Yes. You're the one who stubbed your toe.
Yes, thank you.
Now, in general, your children shouldn't leave their toys on the ground, but still. Go ahead. The supermoon does actually affect the Bay of Fundy because the Bay of Fundy is hypersensitive to tides. For those of you who haven't seen pictures of this, it's this amazing area of northern Nova Scotia where the geology is such that the tides are the highest on the planet and rivers actually reverse directions as they go from low to high tide. There's this one riverbed area where when the tide is all the way out, it looks like the surface of Mars because you have this weirdly cratered rocks left everywhere, desolate area of mud that you don't realize how wet it is till you try and walk on it. Tide rushes in and suddenly you get this beautiful river. If you ever get a chance to go to the Bay of Fundy, I highly recommend it. Now, the difference in tides is about 15% as well. So when you have a 15% more powerful tide, if you have something that's highly sensitive, it's going to notice that 15%. But the way to think of it is 15% of a 6-foot tide, you're not going to worry too much about. 15 foot of a 60-foot tide is something you're going to notice. And so most tides, we just don't notice the difference. Bay of Fundy, you notice.
Yeah. Why is the Bay of Fundy hypersensitive to tides?
It's just the way the land is lined up, is it funnels the water. It's sort of like there's only certain places that get bad tsunamis because of the way the land funnels the water.
The geography?
It's the geography. The surface geology just acts to funnel things effectively and cause the tides to raise and lower much more effectively. It's really, really cool, and it's nothing more than geometry.
Yeah.
This is probably the wrong question to ask this question.
Okay.
Is it possible for tornadoes to form in the area of New York City?
A few years ago I would have said no, but I believe they had one a couple of years ago.
Because there's been several bad movies the Red Box. I didn't think it was possible for
Well, so the reason that you normally say large cities, any large city isn't going to have a tornado, is because the wind patterns that are required to sustain a tornado. You want to have very little disruption. So you want a nice smooth surface. You want cold and warm fronts colliding with one another in a way that triggers cylindrical wind funneling to create the funnel. Well, so a bunch of, you'd think that a bunch of skyscrapers would disrupt the necessary airflows, because normally when tornadoes flow, you end up with the entire collective hot and cold fronts continuing to interact and move generally in a west to east direction across the landscape, and they cause the tornado to move with them. One of the most amazing things to do is to go back and look at the satellite imagery of the set of tornadoes that went through Alabama last year. There was about 300 tornadoes, and there are all of these parallel lines cutting through the terrain, and it's because they were where these two fronts collided. Now, what can happen is, while the tornadoes won't be sustained in a city, the air currents just don't maintain these cylindrical patterns, is if you do get a massive cold front and a massive warm front colliding over the city, you can get sporadic tornado-like events, actual tornadoes, but probably not the F5s that destroy entire towns. And one of the things that you also get is what are called microbursts. This is where you get the sudden whoomp, air just flattens. And I've seen those happen in Boston. So while it's very hard to get the funnel activity in a city just because you can't get enough coordinated airflow, you can get it for short periods of time, and you do get basically giant downdrafts that can do devastating damage on their own. One of the concerns that caused several of my friends to cut me off from reading weather and meteorology journals is, as our ocean temperatures increase, we're going to be looking at having much more extreme differences between the hot and cold air fronts. And this means we're going to get more and more extreme weather. And as someone living in Tornado Alley, not always my favorite thing to read about. But what's even more troubling is the ocean conveyor belts are maintained due to the salinity in the ocean.
Haven't they been altered recently?
They've been altered recently. So what we're seeing is, as all of these large bodies of frozen fresh water melt into the ocean, it's actually changing the salinity of our oceans. And as the ocean's salinity changes, we're not completely sure what's going to happen. And the worst case is that this mid-ocean conveyor belt that takes the warm tropical weather north and keeps England with a nice temperate weather, even though it's like Canada latitudes, that's going to end. And we're going to see extreme dichotomies between much warmer tropical regions and much colder northern latitudes. And this is something that can happen in our lifetime. And so we do have to pay attention to these things, and we will see more extreme weather. Now, it doesn't necessarily mean all of the summers will be hotter. It might mean that you have unusually damp, you have unusually wet. It just means more extremes. And I'm going to start sounding like total weather paranoid person, so I'm going to move on to a different thing. But I do know many astronomers who've opted not to have children because they're afraid of what's going to happen with climate change. And when you have PhD scientists making reproductive choices because they fear for the planet Earth, that means it's worth paying attention to. Now, let me see if I can find something more uplifting to mock before we end this session. So,
Just about anything.
Okay, I'm going to try and cram in two more misbegotten ideas. So, one of them is this notion that the reason the Hubble Space Telescope sees the stars so much better is because it's closer to them.
It doesn't have an atmosphere.
It doesn't have an, right. So okay, my favorite line to use is, haven't we figured out how to fix that cloud thing yet? Yes, it's called the Hubble Space Telescope. So when we launch planets into space, the wonderful thing about putting, not planets into space, that would be glorious. When we launch spacecraft into space, that makes far more sense. The planet's already there. When we launch spacecraft into space, we're getting them above the Earth's atmosphere. And if you've ever looked at stars on a blustery night, they twinkle like mad. And even the planets will be twinkling. Now, if you're on a more normal night, the stars twinkle slightly. Planets don't appear to twinkle at all because they're actually bigger. And that larger point of light on the sky it doesn't get bounced around too much by the atmosphere. On a perfect night, nothing moves, nothing twinkles. And what's happening is our atmosphere is made of pockets of hot air and cold air, and the light gets diffracted and refracted as it goes through all these different temperatures. So we just get above it with the Hubble Space Telescope. Now, the Hubble Space Telescope is located a fraction of a light second above the planet Earth. It's about 400 miles up. Fractions of a light second. The moon is 1.5 light seconds away. So, itty-bitty little tiny fraction of a light second. Moon, 1.5 seconds. Sun, 8 minutes away. Proxima Centauri, over 4 light years away.
A light second means something traveling at the speed of light takes 1.5 seconds.
Yes. So an astronaut trying to call back to mission control from the moon has a 1.5 second lag in his communications, ignoring the computer networks. So one of the you actually get to experience this sort of lag when you see people using satellite phones from other sides of the planet. So that poor innocent journalist over in Egypt who ends up looking really foolish because the person on the nightly news is asking a question and they're standing there. Well, yes, Jim. You know that. We've all seen that. Well, what's happening is their communications is going up to a geosynchronous satellite, probably over to another one, back down. And as it's traveling, it's spending time traveling at the speed of light. We forget light takes time. And so it's taking that time. With satellite phones, it's actually more the light travel time than the computers because it's not that many relays. It's kind of amazing.
Grace Hopper used to give what you called a nanosecond. It was about this long,
Yeah.
the distance that light traveled in a nanosecond, and she had to do this explanation to generals about satellite communication, about how many of it took to get all the way to the satellite.
How high will the James Webb Space Telescope be?
James Webb is actually going to be beyond the moon. So
That will
it's
be closer to the stars then, right? Am I following you?
Well, half the time it's on the other part of it.
No, it'll be a couple light seconds away. So I mean, this is just one of those things where keep in your mind fraction of a light second over 4 years when someone makes that argument. And
You know, Pamela,
yeah.
sorry, but if I may, a serious question, why is the Webb telescope so much?
Why is it so much?
from
Okay, it's actually because the sucker sees in the infrared and we had to put it somewhere dark. So we put it where the sun don't shine. I love you guys. You laugh at my jokes.
Show up to that because I'm telling you, I think you got to show that.
No, I mean to be entirely serious, it's put in a gravitationally stable point beyond the Earth. So it's the sun, the Earth, and then James Webb way out there, such that there's always this continual line where it lives in the Earth's shadow at all times, and this is to protect it from the sunlight. There's various magical gravitational points called Lagrange points where you can balance things so that they stay put. There's one between the Earth and the sun where we like to stick solar observatories. So SOHO lives there. There's another one beyond the Earth where we like to stick telescopes. There's one in front and behind the Earth. We don't generally stick things there yet. So we take advantage of these gravitational sweet spots that keep things in a specific location relative to the Earth, but give them continual observing opportunities. The thing with the Hubble is, it's going around the Earth every 90 minutes. So there's certain objects where you're very limited on when you can observe them, because if the object's over here and Hubble's zipping around every 90 minutes, it can't really look at that object, and it should be looking at something up there. So we like to pay attention to where we put spacecraft. Yes?
Is it true that if you were actually traveling at the speed of light, you could circle the Earth 7 times in 1 second?
That sounds right, but time would stop so it wouldn't matter.
Well, the reason why I'm asking, I don't know what anybody else knows this or not, that's how fast what the Flash was going to be able to do.
No, that sounds right. And one of the things that I have total props for is a lot of comics, a lot of songs, Monty Python, they get the science right. The thing that I really love is there's one time as a high school student, I did as one does, and I figured out if the song, the Galaxy song, had the numbers correct. And it didn't until I took into account that they were in England. And then they were right. They actually made the corrections for where on the planet Earth they were, for how fast they were going around the center of the Earth.
What's the diameter of the Earth?
6,000 something kilometers?
25,000.
Yeah, that sounds about right. Yeah.
How much?
And light is 186,000 per second.
Yeah.
So you're right, the flash would do it.
Yeah, so they tend to get these things right. So as a parting shot, think, question, and don't be afraid to say, I don't know. And realize that there's three things out there. There are idiots. You can't fix them. Smile, escape. Trolling them does no good because they troll back and they're crazy. Then there are people who just don't know yet, or they've been misinformed, and they can learn. Learn to tell the difference. Well, then they're an idiot. So learn to tell the difference and realize that part of the time you're in the doesn't know yet stage, and help someone to understand. And yeah.
Important point to make is because you can't convince the crazies, but
Yeah.
the people that are giving those others equal time, when you're arguing with the crazies, those people that aren't sure are the ones that are your real audience.
Right, right. So fighting an idiot alone, useless. Trolling their comments, useless. Publicly explaining why they're wrong so that maybe the person who doesn't know who to ask, that's where it's useful. One of the things about 2012 that's been really sad for me is the small children, the high schoolers, the middle schoolers who write, is the world going to end? Do I need to worry? Because they don't know. So they're the ones that we need to reach. So be good and learn.
It might end, but not for...
No. So you guys have been a great audience. Thank you.